Hey guys, Mr. Covey here, and sorry I couldn't be in class today. I wanted to make sure you were clear on what we're doing today, and then I'm going to teach you some stuff, so this is going to be kind of a long video with a bunch of different stuff here. So first things first, it is the end of the week. It's Thursday, so I got to read you words of wisdom. I'm just going to give you 2 words of wisdom. Hopefully this helps a little bit. First one here. The days are long, but the years are short. I like that. I like that. All right, one more. When an argument flares up, the wise man punches it with silence. Okay, feel a little bit wiser. That's good. All right, what we're going to do today is I'm going to teach you some stuff about identifying roots. Okay, and then I'm going to do this live. We'll live on this video. And then you guys are going to have that quiz at the end of class. Okay, this is a mini quiz. It's going to last 30 minutes. You need to start this quiz at 1:25. It is on Schoology. It is a timed quiz. If you have extended time, you should start this quiz at 1:10. Okay? You need to take it in the main Google Meet with your camera on. There will be a substitute teacher there, likely Mr. Lakin. Okay? Before I teach you this live lesson here, we're going to look at the quiz directions now, just to make sure we're all clear on the expectations. Okay? It is inside the folder for this week. Okay? It has a timer. You need to click submit before the timer runs out. There's only 7 questions. One of them is an audio question. If you are in person in the classroom, it's probably just easier if you email me your response to the audio question and just kind of type a response. So if you're in the classroom, it's totally cool if you just do a written response to that question. If you're at home, though, I would like you to record a little bit of an audio response to that. Okay, so just so we're clear on Schoology, you go into the folder for today. You should be taking Polynomial Mini Quiz A, or with extended time, depending on if you have extended time. Again, the times that you should start that are, you should start at 1:25 or 1:10 if you have extended time. Okay. Before we do that, I wanted to teach you guys a little bit of stuff relating to identifying roots. Okay, so this is in your notebook if you want to follow along, or just write it down on a piece of paper. This is very, 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 very important. This is review, but I have a feeling you guys don't remember this very well, so we're going to fly through this. Okay. First thing I'd like you to do is pause, take about 3 minutes, and I want you to factor this polynomial. And as you factor it, or excuse me, after you factor it, identify the roots. Remember, roots are x-intercepts. Okay, so go ahead and factor that and find the x-intercepts, the roots. Pause and do that, please. Okay, you should have done factoring by grouping. Okay, so you group the first 2 together, you group the second 2 together. The reason I knew to do factoring by grouping was because there was 4 terms. Okay, when you take the GCF out of the first 2 and you take the GCF out of the second 2, the things you're left with in both those cases are the same. That's how you know your factoring by grouping is working. Okay? These 2 come together to give you one of the factors, and then the factor that's the same for both of those, that's your other factor. Once you have your factor, how do you find roots and the x-intercepts? Well, each factor you set equal to 0. Please be careful that this factor has a squared in it. So when you set that factor equal to 0, you end up getting 2 x-intercepts. Positive square root of 6 over 7 and negative square root of 6 over 7. Kind of makes sense we got 3 roots because we had a cubic function to start. 3rd degree, we got 3 roots. This is all kind of making sense. Okay? This isn't too bad of a problem. I hope you're like, cool, I can do something like that. Read this little, don't look at that. Okay, I'm gonna go back here. Read this little thing here. Okay, so We're not always going to be able to factor. Instead, we're going to have to use our calculator and division. I hope you watched those 2 videos on polynomial long division and polynomial synthetic division. The reason we watch those is because they're going to help us find roots. They're going to help us find x-intercepts. Okay? The way this works is a little bit confusing, so I just want to slow down for a second and think about what it means for something to be a factor, what that word, what that phrase means. Okay? If you think about how this works for numbers, it will help you make sense about how we use this idea with polynomials. So I know you guys know what factors are, but if you ask yourself, why is 6 a factor of 18? Not, is it a factor of 18? Why is it a factor of 18? I know you guys know the answer is yes, but why is it a factor of 18? Think about that. Well, that's because when you do 18 divided by 6, you get a whole number. You get 3. There's nothing left over. The remainder is 0. So because 18 divided by 6 is 3, without a remainder, you know that 6 is a factor of 18. And you might not be thinking about that if I asked you, is 6 a factor of 3? But if I asked you, is 6 a factor of 1,042? Well, you'd do 1,042 divided by 6, and you'd see if you got a whole number or something with a decimal. If you got something with a decimal, that means there's a remainder, and it's not a factor. Okay. Along the same lines, why is 5 not a factor of 18? It's because when you do 18 divided by 5, you get 3.6. In other words, you get 3 3/5. You get 3 with a remainder of 3. When you do the division, it doesn't go in cleanly. You get a remainder. You get something left over. If you get something left over, if your remainder is not 0, it's not a factor. Okay? That's how that idea works for numbers. And this idea works exactly the same for polynomials. So how do you tell if this is a factor of this polynomial? How do you tell if x plus 10 is one of the factors? Well, you can't factor this. You can try and factor it. I just tried it. I couldn't factor this. Factoring by grouping just didn't work. So I couldn't do anything. But I can check if this is a factor of this by taking the red polynomial, dividing it by x plus 10, and seeing what the remainder is. Okay? How do you divide this by this? We use polynomial division. Should I use synthetic division or polynomial long division? I think synthetic division is easier. Okay, so I'll run through this with you, but hopefully you know how to do this because you watched that video. If not, go back and watch that video again. You put a negative 10 there, even though we're dividing by x plus 10. You line up the coefficients. Check, check, check. We go through our synthetic division process. And remember, all I'm really checking here is about the remainder. Remember, the remainder is the last number you get, and it's 0. Awesome, 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 awesome. I got a remainder of 0. That means that, yes, x plus 10 is in fact a factor. Because when I did that division, there was nothing left over. It is in fact a factor. Who cares? So why is it important that x plus 10 is one of the factors here? Really, the important thing is that something being a factor tells you an x-intercept. Don't forget about that important idea. So because x plus 10 is one of the factors of this, it tells you that negative 10, 0 is an x-intercept. Okay? Again, when I say it's one of the factors, this is what I literally mean. I mean, if you take this polynomial in standard form, we can't factor it, we don't know how, but somebody can using some crazy technique. And when they do factor it, probably into 3 factors, one of the factors is x plus 10. That's what we're saying. that if you did factor this, you'd get something that looks like this, with one of the factors being x plus 10, meaning negative 10 is one of the x-intercepts. Yeah. Okay, moving forward. I want you to pause. Go ahead. Actually pause and do this. This should take you some time. To check if x minus 8 is a factor of this polynomial. Okay, go ahead, pause, give it a try. Okay, so when you did this division, again, because the factor was just x minus 8, there was no coefficient there, I used synthetic. I did my synthetic, and I actually got a remainder. It doesn't go in evenly. When you try and divide this by this, there's something left over. Remainder is not 0. That's the That means that x minus 8 is not a factor of this. Okay? So if you figure out that something's not a factor, what it tells you is kind of weird. It kind of tells you two things. Well, first, let's focus on this part first. First, if x minus 8 is not a factor, that means 8 is not an x-intercept. Right? Because if x minus 8 was a factor, then 8 would be an x-intercept. But since x minus 8 is not a factor, it means 8 is not an x-intercept. Okay? So it doesn't tell you anything about x-intercepts. It just tells you 8's not one. It does actually tell you something, but what it tells you is kind of weird. But I'll tell you anyway. Whatever the remainder was is the y-coordinate that goes with the x-coordinate of 8. I'll say that again. When we did this division, the remainder wasn't 0. So x minus 8 wasn't a factor, and 8 wasn't an x-intercept. But if you want to know the y value that goes with 8, the remainder that we did get is that y value. So it tells you that 8, too, is on the graph. This is kind of like whatever. It's just kind of stupid because it's not as helpful as finding x-intercepts. X-intercepts are the points we really want to find. The fact that we have some other random point here is whatever. It's cool, but it's not that important. Okay. All right. Moving on. Go ahead and try number 3. Pause. Take 2 minutes. Actually pause. Give number 3 a try. Is n plus 6 a factor of that guy? Go. Actually pause and do it, please. Thank you. Cool. You should have gotten yes for this case. The remainder was 0, meaning yes, this is a factor. And if n plus 6 is a factor, then negative 6 is an x-intercept. Okay, that's kind of all those connections there. All right, one more here. Is 5k minus 4 a factor of this polynomial? Okay, we're going to do division again, but since 5k minus 4 has a leading coefficient that's not 1, you need to do long division. Again, I need you to be able to do those division processes. If you are having issues with those division processes, go back and watch that division video again. I need you to remember that from AAA AATH. Okay? Okay, go ahead and do that division, please. Pause and do that division. Okay, hopefully you actually paused and did that. And if you do this long division process, you end up getting a remainder. What's your remainder? Negative 3. What does that tell you? It tells you that 5k minus 4 is not a factor. Okay? It means you don't know an x-intercept. What x value is this telling you about? Well, it's telling you about an x value or a k value of 4/5. And it's telling you that 4/5 is not an x-intercept, but that the y value that goes with 4/5 is whatever the remainder is that you got. In other words, if you have an x value of 4/5, you have a y value of negative 3. Again, this is not that cool, but what is cool is that you know that because that's not a factor, well, if 5k minus 4 was a factor, then 4/5 would be an x-intercept. Oops. Over k instead of 4/5. Okay. Then 4/5 would be an x-intercept. But since it's not an x-intercept, or excuse me, since it's not a factor, 4 over 5 is not an x-intercept. So you don't know anything about x-intercepts. Do one more really quick on your own. Pause, go, last one like this. Okay, again, you had to use long division here. Check. It quickly becomes apparent that there's going to be something left over. There's going to be a remainder. So 2x plus 3 is not a factor of this polynomial. Okay. Cool. Okay, moving on. This next question asks us to identify the roots and then write the polynomial in factored form. Okay. So if we want to try and find the roots, we want to try and find the x-intercepts of this polynomial. Our first attempt should be to factor it. Okay, so I'm going to look at that. I'm going to see that I got 4 terms. I'm going to do some grouping. Okay. And I'm going to realize, well, I can take an x squared out and I have 2x minus 3. And what's the GCF with those? I don't think they even have 1. And so I could take out a negative 1. This is not working. Grouping does not work. That's what we were saying before with that here, was that you're not always going to be able to polynomials, okay? So what we're going to use is the idea that if you have a factor, you can divide your polynomial by your factor and get a remainder of 0, and that tells you that this, in fact, is a factor. And we're going to extend that idea a little bit here. Stick with me here. Ready? I don't know any of the roots. I don't know any of the factors for this polynomial, and the only factoring technique that I know, grouping, didn't work. So I am going to go to my graphing calculator. I have to go to my graphing calculator because I have nothing else to do. I have no idea what to do. I'm going to grab my graphing calculator, and I'm going to type that function into my y equals. Okay. Go ahead and do that. When you do that and you hit graph, you get this. So it looks kind of weird, but this is a cubic polynomial with a positive leading coefficient, so I know it goes up and down and up. It just kind of like goes way off the graph. Why did I plug this into my graphing calculator? I plugged it in the hopes that my calculator could tell me one of the x-intercepts. And I definitely see like 3 x-intercepts, 3 roots, but it's really hard to tell what they are. The better way to get that information from your calculator is through the table. So your table should look like this. And when you look at the table and you're looking for what an x-intercept is, remember an x-intercept is an x value that has a y value of 0. So I'm looking through my table here. I see that an x value of 7 has a y value of 0. My calculator is telling me that 7 is one of my roots, one of my x-intercepts. Okay, and if I look at the graph, that actually does make sense because over here at 7, oh yeah, okay, that's one of my x-intercepts. Okay, so cool. I use my calculator. I guess that's kind of cool. I got x equals 7 as one of my roots. But how do I figure out those other 2? This is where the division comes back into play. This is a little bit confusing. Please pay really close attention right here, and I think I will help you make sense of this. So I'm trying to really factor this, but I don't know how to factor it. Why? Because factoring by grouping, which is the only technique I know, doesn't work. I'm going to rely on this idea. Because x equals 7 is one of the roots, I know that x minus 7 is one of the factors. I don't know what the factors are, but I know that one of them is x minus 7. Okay? And I know that there's 3 because it's x cubed. Watch this. Just look at this. So this guy somehow factors to something that looks like this. I know one of the factors is x minus 7. I got that from my calculator. What are the other 2? Well, I need to figure out what those other 2 are. How do I get the pink by itself? I need to do some algebra here. What's the algebra I need to do? I need to divide. Oh, I need to divide the x minus 7. So if I take that line and I divide both sides by x minus 7, I'm left with those missing factors. If you look at the left side, this is the problem we've been doing. Taking a polynomial and dividing it by a first degree polynomial. Okay? If I do this division process, what I should be left with is the other two factors. Okay? Let's do that. Let's take this polynomial and divide it by x minus 7. Go ahead and do that. Pause, do that division. When you go through that process, unsurprisingly, you get a remainder of 0. Why do we get a remainder of 0? Oh, because we knew that 7 was an x-intercept. We knew that x minus 7 was a factor, so of course we got a remainder of 0. But now we're going to actually look at the polynomial we're left with. This polynomial, which remember how you read this is the constant, this is the x term, this is the x squared term. So 15, 11x, 2x squared. This polynomial is going to tell us the other two factors. This is this pink thing. Okay? So I did my division so that I could figure out this chunk here that was going to then tell me the other two factors so I could figure out the other two roots. Okay? Well, this isn't telling me the other two factors. Why? Because it's not factored yet. Go ahead and take 30 seconds to factor this. You guys can do that. Do that. Okay? So now I got that pink chunk. I factored it. And now I know my other two roots. I got 7 as a root from the calculator. 2x plus 5 set it equal to 0. I get negative 5 halves as another root. X plus 3 set it equal to 0. I get x equals negative 3 as my other. Okay? Let's step back for a second. So what I did here was I was trying to find the 3 roots. I didn't know any of them because the factoring technique that I tried didn't work. So I went to my calculator and I got one x-intercept from my calculator. But I could only find one on my calculator. And I knew there was 2 more. How did I get those other 2? Well, I divided the polynomial I had by x minus 7 because I knew that x minus 7 was one of the factors. When I divided by x minus 7, I got a simpler polynomial. I got 2x squared plus 11x plus 15. And that simpler polynomial, when I factored that, gave me the other 2 roots. Okay. So the fact that this polynomial I got out as my answer after the division was simpler than the one I started with is the reason that I was then able to factor. Because what I got here just had a squared instead of a cube. Okay. So also relied on us using our calculator. Okay, let's do one more together here. Okay? I'm trying to oh wait, sorry. By the way, if it asks you to write it in factored form, here is the factored form. Okay? We found the roots and we wrote it in factored form. Okay. Here, ask me the same question. I have no idea how to factor this. I have 5 terms. I don't even have something to try. So what am I going to do? I'm going to go to my calculator. I'm going to type in that polynomial. Go ahead and do that. I'm not even going to look at the graph. I'm going to go straight to the table and see. Oops, sorry. I'm going to go straight to my table. I'm going to look at the graph, but mainly I'm going to go straight to my table. And I'm going to see if I can grab any x-intercepts from my table. Oh, I got one right there. 1, 0 is an x-intercept. If 1 is an x-intercept, then x minus 1 is a factor. So again, if 1 is an x-intercept, then x minus 1 is a factor. If I take my polynomial and I divide it by x minus 1, I'm going to get a simpler polynomial. Okay? Go ahead and do that process, please. Pause, do that process. The simpler polynomial I'm getting out, go ahead, pause. Okay, the simpler polynomial I got out was 3x to the third plus 11x squared plus 8x minus 4. Okay, well now let me factor this. Wait, I still don't know how to factor it. So I still can't factor this. Grouping doesn't work. So I need to go to my calculator again, and I need to ask my calculator, can you tell me one more x-intercept? I'm going to go to my calculator. Oh, cool. -2. So -2 is another one of the roots, is another x-intercept. So x plus 2 is one of the factors. So I'm going to do that division. Boop, 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 boop. I get out 3x squared plus 5x minus 2. Make sure you actually get that out. Now I have something here that I can actually factor. So I had to grab 2 x-intercepts from my calculator. I had to do division twice to finally get down to something that I myself could factor to figure out the remaining 2 factors. The remaining 2 x-intercepts. Okay. So go ahead and pause, take a minute to factor that. I got 3x minus 1 and x plus 2. And now I can kind of put it all together. Okay, I got the answer up here, so I'll pull it up. Oh yeah, by the way, if you're going to have to do this back-to-back division, you can always kind of like stack it into itself. So you'll see what Mrs. Lemke did is she did one synthetic division problem, and then she just took the answer and like made it right into another. Kind of nifty there. Both times she got remainders of 0 because she knew what she was plugging in was going to give a remainder of 0. She knew that those were x-intercepts because she got them from her calculator. There's it all factored up. Check. Again, these 2 factors were grabbed from the calculator by looking at x-intercepts. This is what was left over, and this we just actually factored by. What you'll notice is this polynomial, although it was 4th degree, it only had 3 roots. Why is that? Well, it's because one of the roots showed up twice. If you go back to the graph, what happens when a root or a factor shows up twice, has a squared on it? Oh, it bounces at that x-intercept. Okay, so it's kind of all tying together with what we were talking about with the graphing. Okay. Don't forget, though, asking your calculator is a last resort. Okay. Go ahead, pause. I want you to give all 3 of these problems a try. Remember, your first try should be, maybe I can factor this on my own. Only if you can't factor it, do you then have to ask your calculator for one of the roots. I'll give you a clue. 2 of these 3 you can factor on your own. One of them you need to ask your calculator. Okay, so go ahead and do example 3, example 4, example 5 on your own, please. Pause and give those a try. Okay, so let's kind of go through these one at a time here. For number 3 here, when you're trying to factor this, the first thing I look at is I say, when everything has an x, I can take out a greatest common factor. I can take out a greatest common factor of x squared. What I'm left with is this, which still has 4 terms. So the factoring I need to try there is grouping. The grouping ends up working. I get to right here. I have a feeling a lot of you guys got stuck here and stopped there. You can actually keep factoring. This is difference of 2 squares. 4x squared minus 9. What squared is 4x squared? 2x. What squared is 9? 3. Factor some more. And now I have it fully factored. Each factor tells me an x-intercept. So I get 0 from the x squared, -4 from the x plus 4, and then I get 3 halves and -3 halves. Okay. Here's the factored form. Here are the roots. Did not need to use my calculator because I could actually factor it. Same with example 4. I could just do grouping. Again, be on the alert here. After I did the grouping, this factor that I had could be factored more. It was difference of 2 squares again. It ended up giving me out 3 roots. Here's the factored form. Here's the roots. This last one, number 5, I couldn't factor. It had 5 terms. You can't factor stuff with 5 terms. So I went to my graphing calculator, and I figured out that -2 was one of the x-intercepts. So I divided by x plus 2, which means I put a -2 here. I know I did that right because I got a remainder of 0. I still couldn't factor this. You can try it again. Or Mrs. Lemke just said, I'm just going to grab another x-intercept from my calculator. Did division again. What she got down to after she did both those divisions was a quadratic, which she knew she could factor. That quadratic she factored like this. Combine that with the two factors that she got from the calculator. And she figured out that there are only two roots. It's because these factors repeated. Okay, so here's the factored form. The only roots were -2 and 5, but they both showed up twice. If you type this into your calculator, you would see that at 5 and -2, this graph bounces. Okay, because both those factors have multiplicity 2. Okay? This right here is kind of the summary chart of how this all connects. Okay, so if you know that x equals a number is a solution to the equation being equal to 0, that's equivalent to saying that that number is a 0 of the polynomial. If that number is a 0, then x minus that number is one of the factors. Another way to think about that means that that number a is an x-intercept. A0 is an x-intercept. So please keep in mind these are all the same thing. A solution to an equation equal to 0 means that number is a 0 of the polynomial, which means it's an x-intercept, which means x minus that number is a factor. Kids get confused because they think these are all like different questions. They're all the same question. They're all directly connected to each other. Okay? What we talked about in this video is not on your mini quiz. Okay, but it is important for you to know, and we are going to do practice with it next week. Okay? So depending on how much time you have left, here's what I want you to do. If it's approaching 125, whenever it turns to 125, please take your polynomial mini quiz on Schoology. If you have time before then, there's a couple things you could do. You could just review for your polynomial mini quiz, look at the stuff from class on Monday, make sure you're all totally good with that, look back at the Desmos, look back at your problem set. Actually, that's what you should be doing. Cool. So make sure you do that until 125, and then I want you to start in that polynomial mini quiz. All right. We'll practice all the stuff we talked about in this lesson on Monday. And that's it. Thanks for working hard, guys. I appreciate it.